Now this video is all about graphing radical inequalities in two variables. The last video was one variable, so you just had x and you were solving for x and used the number line. Here we have two variables, y and x. So when we're graphing this, we're going to use a Cartesian plane, which is made up of two number lines, one for the y and one for the x. Cool. So what we have done before with graphing inequalities, this is pretty much going to be the exact same process, so there's nothing difficult in this. There's just one thing we'll have to look out for at the end. So if you remember when we talked about graphing these equations, they're shaped like half of a sideways parabola. So what I'm going to do first is find that point where the graph ends, because remember there's a point where it ends and there's an arrow on the other end. And the point where it ends is always where the domain starts, and the domain is where the radicand, if it's a square root, has to be greater than or equal to 0. If it was a cube root, you would just basically pick that middle point. But most of the ones that we're doing here are going to be square roots. So I'd solve this and get x is greater than or equal to 3. So my starting point is going to be at 3. When I plug 3 in, I get 2 times the square root of 0, which is 0, plus 1, so that's 1. So that's going to be the point 3, comma 1. And then I'm going to pick numbers that give me nice convenient values. So the first one I think would be 4, because that gives me the square root of 1 times 2 is 2 plus 1 is 3. And I think the next one would be 7. So that would give me 5. And then the last one would be 12. And that would give me 7. So let's see. Got a lot of tick marks here. And I will tell you, because I'm freehanding this, it's not going to be the prettiest graph, but I think we'll get the point across. So I got the point 3, 1. That's right there. I got the point 4, 3. It's right there. 7, 5, and then 12, 7. Now, that's what the boundary is going to look like. So we would ask ourselves, is this boundary going to be dotted or solid? And remember, it's solid if it's an equal to, because you're including the boundary. If it's not equal to, it would be dotted or dashed. So in this case, it's going to be a solid boundary. I mostly hit the points there. Mostly. All right, so now we need to figure out which way to shade. So here we normally have used a test point, right? And test points that we've chosen in the past have typically been 0, 0, because 0, 0 is super easy to plug in. There's a problem with picking 0, 0 here though. And it's, if I plug 0, 0 in, 0 is not even in the domain of this function. So I'll get an imaginary number back if I plug in 0. So I need to pick a point that makes sense, that's actually in the domain of this thing, to see if it works or not. So I'm still going to try to keep a 0 for the y, but maybe I'll pick the point, I don't know, 4, 0. That's below the graph, so I'm testing it to see if the stuff below works. So when I do that, I plug that 0 in for the y, and I plug the 4 in for the x. And that will give me 2 times the square root of 1, which is 1, times 2, which is 2, plus 1, which is 3. 0 is definitely not bigger than 3. No. So the stuff that's below, which is what I was testing, doesn't work. The stuff that's above does work. Now, there's one thing you have to watch out for when you're shading on these, and that is the fact that if I just shade above, if I do that, I'm shading a whole lot of stuff over here that doesn't even work in the inequality, because there's a domain stoppage, right, where x is 3. Nothing less than 3 works for x. So when I go to shade, let me have my undo here to get rid of all that. What I like to do is to go ahead and mark where my domain needs to end, and that's at x equals 3. Now I'm just marking it. I'm not including it, but I'm marking it so I know not to shade past that point. And that way, when I go to shade above, which is the area that works, I shade, but then stop at that value, and I'm not shading anything that doesn't work. So the process for this, again, is figure out where the graph the boundary, basically, sort of like finding where the half sideways parabola ends, getting your points, figuring out if your boundary is dotted or solid. I like to go ahead and mark where the boundary ends once I draw it, and then using a test point to figure out which way to shape.